Section 9.3, your second video of geometric sequences. In this video, we're applying geometric sequences to specific types of problems. As you can see at number 1, this is an investment. Jim finds out what he had in his checking account over the last 5 years. He started with $100. It went up to $103. It went up to $106.09. And it's increasing geometrically, which means there's a common ratio. And what we need you to do first is find out what that common ratio is. Again, if you're not clear on what the common ratio is, obviously it's a growth problem, but you can simply take the second term divided by the first term. So $103 divided by $100 is 1.03. That becomes our common ratio. Now we want to know what Jim will have on the 16th year, which obviously is the 16th term in our geometric sequence. So what we're going to need to do here is come up with an explicit formula and then simply insert the 16 in for n, which is our term that we're looking for. So here we go. A sub n is equal to, if you recall on the previous page, our first term is $100. That's a sub 1 times our common ratio, which is 1.03 to the power of n minus 1. This particular formula, as long as this pattern continues in his checking account, will represent any value of any amount that he has at any given time. So we want the 16th year. So we simply do this. Put 100 times 1.03 to the power of 16 minus 1. And that will give us his amount in the checking account. If you evaluate this on your calculator, you come up with $155.80. That would be your value on the 16th year. So this is an example of how you can use an explicit formula to help you in a setting. Of course, the pattern has to increase by 3% each year. The next one we're going to look at is a swing problem, and let's read through it first to see what they're asking us to do here. And I try to diagram it out, the swing, and I think most of you have had experience on a swing. You'll notice that the arc of the swing is less and less as you go through the number of swings here, and it's geometrically less. But let's read the problem. Because of the wind resistance, when a child swings without being pushed, the length of the arc decreased geometrically. Find the missing arc. Well, essentially they're asking for how many feet would this be. What you're doing here is finding the common ratio. It's geometric. We're multiplying. If we multiply 6 and 1/8 times the value, we'll get this, and that times that will give us 8. The formula for geometric sequence would be the square root of the product of the two terms. So we take 8 times 6 and 1/8 and then square root that result. Without a calculator, here's how you would do that. You put 8 over 1, and 6 and 1/8 is 49/8 as an improper fraction. 6 times 8 is 48, plus 1 is 49. The 8's reduce, and you're left with 49. And then you take the square root of 49, which gives you your missing length here of 7. So we're looking at a 7-foot swing pattern here. The common ratio, again, it can be found by taking either 8 divided by 7. That's probably the easiest way. 8 divided by 7 would be a common ratio of 8/7. Or if you want to write that as 1 1/7. If you divided 7 divided by 6 and 1/8, this is how you would do it without a calculator. 7 over 1 divided by 49/8. And remember how you divide fractions. You get 7 over 1 times 8 over 49. And then 7 goes in the 7 once, and there, and the 49 7 times, so you end up with your 8/7 that way. So it's consistent, but 8/7 or 1 1/7 would be your common ratio. And I use this one, so that's how you find it if you can't determine by looking at it. You actually have to divide it out. So hopefully this lesson went well. Good luck with it. Let me know if you have any questions.